Performance is crucial to all software applications. Very often, users become easily impatient when forced to wait while an application processes their requests. Web application designers have to be especially cognizant of performance because they have to contend with limited bandwidth and a potentially large number of users for very successful sites. The default behavior of ASP.NET is to recreate each web page every time it's requested in its entirety. However, sometimes your content doesn't differ for every request. Caching lets you save pages, or just sections of pages, in memory and retrieve them from memory upon request instead of recreating them from scratch every single time. Sometimes content is shareable amongst multiple users. Other times content is only reusable among requests from the same user. The idea here is that if content doesn't change between web requests, it's wasted effort to perform the steps to regenerate it every time a user requests a page. If to generate a page, you have to hit a couple different databases, process data, do all kinds of actions that can take a significant amount of time, then you can benefit from caching. The nice thing is that ASP.NET supports a rich variety of caching techniques that can dramatically improve the performance of a busy website. In addition to caching pages and page fragments, you can also cache data as objects. So you have a lot of flexibility. Unfortunately, which content that you should cache is not something the web application can easily figure out in an automated kind of way. So you're going to have to define the caching features necessary to improve performance. And as you'll learn in this module, the ASP.NET Framework and MVC provide a variety of tools that you can use to implement caching on both the server and the client. At a developer conference early in the life of ASP.NET, Scott Guthrie, the person at Microsoft who's generally considered the father of ASP.NET, was asked to name his favorite feature. Without hesitation, he said that he thought the feature that would cause the most excitement among web developers is ASP.NET's rich and innovative support for caching. Now, this is kind of old news. ASP.NET is going on, well, it's well into its second decade of existence, so it's old news. But time really has borne out that conviction that this is really a very sweet feature of ASP.NET. And the nice thing here is that because MVC is built on top of ASP.NET, it can take advantage of all of the services that are provided by ASP.NET, in addition to providing its own caching features. So you really have the best of both worlds, and you have tons of flexibility in how you implement caching in order to enhance the performance of your web applications. Now, we generally need to consider 4 scenarios when we talk about caching in a web application, and specifically within an MVC4 application. The first is that you can cache individual data items that need to be accessible in different scopes and for different lifetimes. This can range from the course of a single request from a single user to across all requests for all users over time, as well as everything in between. Another scenario is full page caching. This is where the entire page is cached in its entirety. In an MVC application, that generally means an entire view, including any partial views that are included within it. Then another scenario is partial page caching, and specifically what's called donut caching. This is where you cache the entire page, except for one or more small sections. So again, that's called donut caching because you're caching all but a few holes in the page. Unfortunately, this isn't something that MVC supports out of the box. But as you'll see, it's not hard to implement at all. And then the fourth scenario is another version of partial page caching called donut hole caching. This is where you cache one or more small parts of the page, but not the page in its entirety. So donut hole caching is the inverse of donut caching. Fortunately, MVC supports this scenario natively, making it very easy to do, as I'll be showing you. One of the questions that you're going to need to consider when you're designing caching for an application is where you want the data to be cached. And here I'm talking generically data. It can be HTML, it can be individual data points, it can be a combination. So web application caching is generally done either on the server or the client. And that just means where the cache data is stored. Usually in memory, but there's other options as well. So the first option, as I mentioned, is server-side caching. This focuses on the ways that the server generates or retrieves data in response to a user request. The objective here is to limit the amount of work required to process a request for data. If data is cached, this both saves the time required to respond to the request, as well as lightens the load on the server by reducing the need for resources that are required to process that request. And ASP.NET and MVC both have rich resources built in that support server-side caching in very flexible ways. And then the other general option is client-side caching. This requires support in web browsers, which is available in all modern browsers, and HTML5 even expands those options further. The nice thing about client-side caching is that it can entirely eliminate a request to the server. If the needed data is already within the browser's cache, the request isn't needed, so nothing goes across the network at all. That way, the page responds more quickly to the user and frees up server resources to handle other requests. Now, there's different options that you can use. So rather than requesting an object from the server again if it's in the cache, the browser can also check to see if the data that it has locally is fresh or not. And it can make that kind of a request or a question to the server without necessarily needing to download the object again. So there's a lot of options with this. All right, so all this begs the question, which option should you use? Well, quite frankly, it's a balancing act. There really is a fine line between too much caching and too little. So, as a developer, you need to find the right balance based on the design of your website and the data that it exposes to the user. Part of this is deciding how long data should be cached, its expiration date and time, so that you avoid providing users with stale data. So that's always the difficult part. You don't want stale data. If you've just done a big price increase across your catalog, you want to make sure that the users are seeing the current price, even though you only change prices every 3 years, so that's a prime candidate for data to cache. Okay, so both server and client-side caching have their uses, and neither is necessarily better than the other. In fact, you'll likely use a combination of techniques in a single website, and maybe even within a single web page, depending on the user needs and how you build the page. There are a surprisingly rich number of server-side caching techniques that are available in ASP.NET applications. Most of the options are provided by the base ASP.NET framework and support caching in both web forms and MVC applications. In some cases, MVC has features that hook into ASP.NET's caching features, but in others, they're just native features that you can still hook into. So I'll cover some of the server-side caching techniques that are part of ASP.NET and available to any web application. I'll start with those with the narrowest scope and move to the widest scope, and generally from the simplest to the most complex. Keep in mind that you can often combine techniques to achieve exactly the results that you need. And it does take a lot of trial and error in order to fine-tune the performance using caching. There are 3 basic techniques that are built into ASP.NET with massively varying scope. They're focused on caching data as opposed to HTML and other page artifacts. So one of the features is request caching. In this case, every request from the browser causes .NET to create a new instance of system.web.http context as the central point of interaction between components involved in handling the request. This form of caching can use the items property of that HTTP context object. And that's just a dictionary object that exists during the lifetime of the request. So you can read from and write to that object during the request. So this is a great place to store data that's relevant only during the current request. And what it does is it fosters loose coupling between the components. So it's essentially a notepad where you can persist data during the course of a single request. Now, because it's a dictionary object, it's not strongly typed. So if data is not a string, you have to cast it before using it within a strongly typed variable. And that's kind of a recurring theme with some of the collection objects that support caching. Another option is session caching. This takes advantage of session state that lets you store data between multiple requests as long as the user session is active. And this data is scoped only to that session. This option uses the HTTP context session object, which is available through a property of that same name within MVC applications. The session object is also an untyped dictionary object. And you have to have session state active in order for this to be an option. So it's built on top of session state. Then another option is application caching. This is a good place to store data cached for an entire application across all requests and across all user sessions. So it's a great way to share updatable data. This again is an untyped dictionary object, and it lives for the lifetime of the application. And that's the lifetime of the IIS worker process that hosts the application instance, which could go away after a period of inactivity. So you'll generally need to provide for reinitializing values in the event of an application restart. But that's going to apply to just about any cross-session caching techniques. And then the last broad option for server-side data caching is the ASP.NET Cache object. This is an object that's managed by ASP.NET that, in most cases, provides a better option than application caching. And this makes use of the HTTP context cache object. I'll talk more about this option after we look at some samples that use the first three data caching options. All right, here I have the sample caching solution. And what I'm going to do is explore first request caching. So I'll go ahead and start by running the application in Internet Explorer. All right, and I'll click on request caching. And this is one variation. It's a request caching variation on a page that I'm going to use to show you several different caching techniques. So what the page is doing is I have some beginning values, just some data points that I want to use over the course of this request, and later for a wider scope or a wider lifetime. So here are the beginning values. When the user first requests the web page, these items have no values. So new user, empty, user category, empty, time, empty. And then at the end of the request, during the course of the request, I generate values for those data points. So you can see new user is false, whatever that means. User category is platinum, and the time is 9:14 a.m. And then the code also displays some values from the HTTP context object directly. And as you can see, those are nicely coordinated, these two sets of values. And then here I display the non-cache time. As you can see, it's slightly off, but pretty close. Okay, so now what I'm going to do is I'm going to refresh the page. And there you can see that 9:15:57, and these are all in sync. I'll do it again, 9:16:03 and 05, and so forth. So as you can see, these, quote, cached values are always being refreshed and are staying more or less in sync with the non-cache time. Okay, so that's how this version of the page works. Let's take a look at the code. Keep in mind that this is request caching, so we're only caching the values over the lifetime of the individual request each time I request the page. Okay, I'll shut this down, come back over here to Visual Studio, and take a look at the home controller. Okay, so the way this is laid out is the base action methods, basically the default methods that are created with a new MVC Internet application, are unchanged. So I have index, about, and contact, and that provides some of the user interface features. Okay, so nothing interesting there. So here's where the code that I'm talking about in this section is. So here's the request caching action method. And as you can see, what I'm using is the items collection of the HTTP context object. So again, this is an object that is created for each ASP.NET request. When I first am making a request to the web server, the items collection is empty. So if I attempt to read values from it, those are going to be null. So isNewUser is null, user category is null, time's null. So I'm saving those within a view bag, and that's the reason why that first set of parameters, the top parameters on the page, were blank, because these were null values. So as you can guess, within the view, I'm just using these same properties of the dynamic view bag object in order to display values. All right, then the next thing we do is that if isNewUser is null, it's just a marker to indicate that things are null and haven't been set yet. If it's null, I go ahead and set some values. So isNewUser false, again, whatever that means, user category platinum, whatever that means, but they're real values that are being set within the application. And then I'm also reading the current time. And then have a comment here that I typically would do some other work that produces the response to that user page. And then what I'm doing is then saving the current values of those HTTP context items in the isNewUser after, user category after, and time after. And so that's why I can display those values as the after values within the view. And then I just return the view. Okay, so let's take a look at the request caching view now. Things in the home controller. And very simple page. All it's doing is just reading the various values, the before values, the after values, and then it's also directly reading those context values so that we can compare them to the before and after values. And then here's the non-cache time. And so as you can see, this is not being read from any cached object. And so it's just displaying the current time when I refresh the page. Okay, so now you can see why we got the behavior that we did. So these are always null because every refresh that I make, every request for a refresh that I make, is generating a new request to the server. Those values are null. Again, if we come back over here, those values are initially null for this request. And then the ending values are the values that were generated within that action method. So those have values. And then when we read the current request values directly, those are going to match up with these values. So for this version of the page, these are always going to be null. These are always going to be current values, including the current time. And these are always going to be current as well. Okay, so request caching is the narrowest scope of caching. Just exists for a single request. So may not seem like it's all that useful, but it actually can be useful when values need to be accessible throughout complex processing in response to a single request, particularly if you're bouncing back and forth between components that make up this MVC page. Okay, so now let's talk about session caching. I'll go ahead and run the application once more, and this time click the session caching option. Okay, so there's the page. As you can see, this is pretty much like request caching. The beginning values are initially null, don't display, and then I have the ending values, and then the values from the HTTP context, reading it directly. And once again, the non-cached time. Okay, so the behavior at this point is just like request caching because this is the first request. And in this case, the time is in sync with the non-cached time. All right, now I'm going to refresh the page. As you can see, now we have beginning values, and it matches the ending values and the HTTP context values. But notice that these cached values are out of sync with the non-cached time. So remember, this is dynamically generated every time I make a page request. The cached values were cached, approximately 46 seconds previous to that. Okay, so I'll go ahead and refresh a few more times. Refresh. Notice the cached values aren't changing. But notice that the time is being updated each time. Well, as long as I don't do it more than once a second. And so the cached values have gotten more and more out of sync with the current cache time. Okay, so let's look at the code for this page. Come back over to the home controller. And here you can see that I have pretty much identical code, except that this time I'm using the HTTP context object's session property, which exposes a session object. And this is how I get the different lifetime for these values. These values are now going to exist for the lifetime of the session. So if I'm a user, I'm navigating to different pages, I spend 3 hours on the website, assuming that I stay active enough that the session doesn't expire, which by default it does in 20 minutes, then these values are going to remain available to the user. All right, so they're initially null first time I run this for the session. Then I update the values, do some other work, and then read the cached values as well. And putting them in the view bag, same as the previous example. Then if I look at the view, open that up, it's pretty much identical to the previous example for request caching, other than using the session object down here instead of the HTTP context items collection. Okay, so session caching has a wider scope. It lasts until the current user session expires or is abandoned. Okay, so I'm going to run the application again. Once again, go into session caching. So there we have the initial values. And what's kind of interesting here is that in some scenarios, Visual Studio will save the session for you because I'm running it within Visual Studio, but obviously not in this case because the cached values are synced up with the current time. But now I'll go ahead and refresh this a few times, and the cached items get further and further out of sync with the non-cached time. Okay, same behavior as before. So again, this data is going to be stored within that session object until the session expires. And so that's going to be after 20 minutes of inactivity. Or you can also explicitly abandon the session. All right, so I'll refresh this a couple more times. Cached items get further and further out of sync. And then I'll abandon the session. Click on that, and notice that I'm starting over from scratch. Initial values are empty, and these cached values are in sync with the non-cached time. But now I have a new session, and I'll refresh, and I got the same behavior before. Okay, so if we go back over to the home controller here, here's the code for abandoning the session. All you have to do is execute the abandon method on the session object, and then that session is gone for that user. But then I immediately redirect to that same action method, and so the process starts over again. So this is a little bit artificial. I explicitly went back to that page, which then started a new session for that user. Okay, so that's session caching. The third option is application caching. So go ahead and run this again, and select the application caching link. Same basic page. I've started up a new instance of the app. Again, Visual Studio in this case is not caching the application, which it sometimes does. And so the initial page behaves like the other two pages that I showed you. Initial value is null, and then we now have cached ending values. And if I refresh the page, I now have beginning values, and as I continue refreshing the page, they get further and further out of sync with the non-cached time. Okay, so same overall behavior. Okay, so now what I'm going to do is I'm going to copy this URL, and I'll start up Firefox. And I'll right-click in that and select Paste and Go, an option that I wish Internet Explorer had. And it loads that up. And as you can see, because this is running the same application, the cached values are saved across users. And so I have the cached times, which are out of sync with the current time. So there you can see it has both a wider lifetime and a wider scope across user sessions, because I'm using the application object to do that caching. All right, if I shut down this, down that, application ends, and here's the code for application caching, identical to the previous code other than using the application collection of objects within HTTP context. And then the view is pretty much identical as well. Remember that there's a fourth option within ASP.NET and MVC applications for caching, and that uses the cache object. This is generally a better option for caching than application state. It's a little bit more reliable. You have a little bit more control over it. System.web.cache is a dictionary object like some of the other caching objects that I've shown you, but it's not limited to individual requests or user sessions. So it works kind of like application state. But it can cross worker process boundaries. Because it's part of ASP.NET and not IIS, unlike application state, it's generally more reliable. ASP.NET automatically manages removal of cached items, notifying applications when it does that. So you can repopulate items, refreshing them. And what it does is it removes items when any of three things occur. The first is that the cached item expires. So you've set an expiration date and time on it. That time goes by, and so it's removed from the cache. Second option is when the cached item's dependency changes, and that invalidates the items that are linked to that dependency. So file changes, data within a SQL Server table changes, any of a number of things that you can set up to make the cached items dependent upon. And then finally, ASP.NET can also remove items when the server runs low on resources and has to reclaim memory. So keep in mind there's three different scenarios under which ASP.NET will automatically remove cached items. The process of removing items from the cache when it's running low on memory is called scavenging. Priority items for removal are those that haven't been accessed for a while, and those that are marked as low priority when you add them to the cache. And when ASP.NET scavenges items, it fires the cache item removed callback. And that notifies an application that something has been removed, so you can recreate the objects as necessary. Now there's some expiration options. These indicate how long a cached item should be kept before it expires and is no longer available. One option is to use sliding expiration. In this case, the item expires a specified amount of time after it was last accessed. So for example, if you set this to 30 minutes and you access the item every few minutes, it'll stay in memory indefinitely, unless it's removed for some other reason. And then another option is absolute expiration. In this case, it expires at a specified time, no matter how much or how little or how often the item is accessed. So if you expire the item at midnight, it's no longer available after that. It's kind of like Cinderella's goodies, except that those at least reverted to their original form. In this case, cached items just go away completely. And you can only set one expiration type, either sliding or absolute, for each cached item. Now let's talk a little bit about cache dependencies. The idea here is that you define dependencies that define the cached item's lifetime. If the dependent item changes, the cached item is removed. So, for example, if an item is dependent on a file, if the file changes, the item is removed. And there's several different kinds of dependencies that you can define. One is an aggregate. This combines multiple dependencies. So, cached item is removed when any of the dependencies change. And this is a great way to create complex dependencies based on various kinds of changes. So if you have a cached item that's dependent upon data within a database, the contents of a file, and maybe a third condition, you can use an aggregate dependency in order to expire the item when any of those three things change. Another option is a custom dependency. In this case, the cached item depends on a custom class that's derived from system.web.caching cache dependency. And the sky's the limit in how you define the dependency, based on anything that you can write and access within code. Then a file dependency depends on an external file. So the cached item is removed when the file changes or you delete it. Another dependency is a key. In this case, the cached item depends on another item in the application cache. So this item is removed when the target item is removed from the cache. So it's a great way to create interdependencies between multiple cached items. So you don't necessarily need to manage all of those individual items. You can make them dependent upon one another, so if one goes away, other items go away. And then the final option is SQL, a SQL dependency. In this case, the cached item depends on changes to data in a table in a SQL Server database. And the item is removed when the data changes. So the idea here is that you get the notification that the item has been removed from the cache, and you can use that to trigger the stored procedure that extracts the data, and then you can refresh that cached item. And in that case, it uses the fresh data from that table. Okay, here I am back within the caching sample application. So now I'm going to show you some of the features of the ASP.NET Cache object, including how you can use its dependencies feature. All right, so I'll go ahead and run the application in Internet Explorer and select the ASP.NET Cache object. So most of this page behaves like the previous examples. Have beginning values that are null, and then some ending values that were generated within the action method, and then reading the HTTP context values directly. But then I also have some dependency information down here and some expiration information. Okay, so I'll go ahead and refresh the page. And as you can see, I yacked long enough that the item expired here. So I created a cached item that expires in 10 seconds. I talked for more than 10 seconds, refresh the page, that item is out of memory. And then I also talked long enough so that the sliding expiration went by as well. All right, so I can go ahead to refresh this page. There we go. And you can see that I have cached values, and they get further and further out of sync with the non-cached time. Okay, I'm going to shut down the browser and then run it again and go back to the same page. And notice that I still have cached items, but the items that went out of memory when I started the application are still out of memory. And I can continue to refresh, and at that point, the only thing that's going to change on this page is the non-cached time. All right, so I'm caching different values using different options of that ASP.NET Cache object. So let's take a look at the code. All right, so here's the ASP.NET Cache action method that works behind that page. All right, so the first part of it, once again, I'm reading data from that ASP.NET Cache object. Keep in mind that this cache object has a very wide scope and a long lifetime. So it's going to stay in memory across all user sessions. Okay, so initially I have no values, and so these values are null. And then I update the values, same thing as the previous example. But here's where things get a little bit different. So now what I'm doing is I'm creating an item here within the cache object called file dependency. I can associate some data with it, and then I create a dependency using system.web.caching.cache dependency. In this case, I'm making it dependent upon a test.txt file. All right, so I have Windows Explorer open. Go over here. There's my local disk C, the data directory, and I have no file there yet. So the folder exists, but test.txt is not there yet. Okay, so that's how you create a file dependency, and I'll show you how that works in just a moment. And then I also create a new item that's dependent upon the isNewUser. So this is called key dependency. The message is isNewUser exists. And then I once again use this cache dependency object in order to create a new dependency upon this cached item. So this is the key, the string key, into that cached item that I created right here. Okay, other thing I did is I created a couple cached items that expire after a period of time. So this first one is going to expire in 10 seconds, and it's set to an absolute time. So once again, name it, a message, this is actually the data that is saved as the cached item. And then I'm just taking the current time and adding 10 seconds to it. And so that is going to define when this item goes out of memory. So it's 10 seconds from when I first load the page. And then this option expires in 10 seconds, which is set as a time span from the current time. So as you can see, I'm using a time span object with no absolute expiration. Remember that you can only use one of those options. And so this is going to expire 10 seconds after the last activity on the cache. Okay, and then the rest of this is just saving the values, the current cached items, within that view bag, and then returning the view. Then if I go over here, take a look at the view, again, all it's really doing is reading the values from either the cache or the view bag to display them on the page. All right, so let's go ahead and run this again. And refresh a few times. As you can see, I still have the cached values that are out of sync with that value there. This item was already created and went away, so those are expired. New user still exists, and so we still have that cached item available. But now I'm going to go over and create a test.txt file. And I'll go ahead and open it in Notepad. But I'm not going to add any text yet. So now I'll go back over to Internet Explorer and refresh. And as you can see, because I created the file, this dependency has now gone away. So you can see how a file dependency works like that. If the file had already existed when I first loaded this page, then I would have to go into test.txt and either delete it or add text to it to change the contents and save it. And that would cause the cached item to go out of scope. And in that case, probably in a real application, what I'm going to do is see that the file had changed, it was created, it was deleted, or whatever, and I would automatically respond to the event that's fired and recreate that cached item with that file dependency. And the usual scenario is that I now have a cached item that has been refreshed with the current context, the changed context of that text file. So as you can see, there's some very flexible options for using the ASP.NET Cache object.